Hello everyone, this is Safo. Welcome back to this MATLAB Control Systems Series. In today's video, we're going to simulate and analyze the overdamped second-order system step response. Let's get started. First, here, I clear the workspace, close all figures, and reset MATLAB. Next, I define the system parameter. K is the system gain, omega n is the natural frequency, and zeta is the damping ratio. Since zeta is 1.5, which is greater than 1, this is an overdamped second-order system. Okay, here I define the transfer function using the standard second-order system for. And here I display the transfer function in the command window. And finally, I plot the step response. Okay, run. Shows a classic overdamped second-order response. Because the damping ratio is greater than 1, the system has no oscillations at all. The response rises slowly from 0, curves gently upward, and gradually approaches the steady state value of 1. Compared to underdamping systems, this response is slower but completely smooth and stable. This behavior is exactly what we expect from an overdamped system. And thanks for watching. If you're following this playlist, don't forget to check out the next video where we continue exploring dynamic system response in MATLAB. See you in the next one.